Question 5. The diagram shows a cycle track. There it is. The track has two straight sides, each of length 40 meters. Each end of the track is a semicircle of radius 27 meters. So these two sentences are just describing the picture up here. The diameter of each wheel of Ian's bike is 590 millimeters. Notice that the units have changed here, so that's something we're going to have to keep an eye on. Ian is going to ride his bike around the track once. Calculate how many complete revolutions each wheel of his bike will make. Now, there's a lot of information in this question and a couple of different ways of doing it, but whichever way you do it, you are still going to have to know about how to calculate the circumference of circles. So to start, I decided to calculate the length of the track. It will be worked out by adding together the two straight sides, so 40 plus 40, and the circumference of the two half circles at the end. Bear in mind the circumference is the distance around the edge of the circle. And I hope you can see, if I put the two half circles together, I will have one complete circle. This question is assessing whether you know, this box highlighted in yellow here, that the circumference of a circle is given by pi times the diameter. Don't forget the diameter is a distance across the circle from one side to the other that goes through the middle, so it's going to be 27 plus 27, which will be 54. Timesing that by pi and adding it to the two straight sides gives you a total track length of 249 meters and 64 centimeters. Now, Ian's bike has a diameter of 590 millimeters. Because we're working up in meters here, I think it's sensible to work in meters throughout the whole question, and 590 millimeters is 0.59 meters because it's equivalent to 59 centimeters. To work out how many complete revolutions the bicycle wheel makes, I need to know how far it travels each time there's a revolution. So in other words, I need to know the circumference of Ian's bike wheel. Again, that formula is pi times the diameter, and I've just worked out the diameter here. So I need to do pi times 0.59 meters, which comes to 1.85 meters. So each revolution of the wheel on Ian's bike takes the bike through 1.85 meters. Now we know it has to go through 249.64 meters, and I'm going to divide that by the 1.85 that the bike travels each time the wheel goes through a full revolution. And that gives you 134.9 revolutions. Now if we go back to the question, it says calculate how many complete revolutions each wheel of his bike will make. So the bike is going to make, or each wheel of the bike is going to make 134 complete revolutions. It would be tempting to round this up to 135, but that wouldn't answer the question because the bike wheel isn't going to make 135 revolutions to get around the track, so we give the answer 134.